Cycloalkanes and their stability. Video lecture presented by Mrs. Afroz Patan, Department of Pharmaceutical Chemistry and Analysis and School of Pharmaceutical Sciences. The topics which I have covered are definition of cycloalkanes, nomenclature of cycloalkanes, stability of cycloalkanes, which is discussed under Bayes chain theory and his assumptions. And merits and limitations also I have in detail explained. And later I have explained Sachet-Mode theory, which clearly explains the limitations of Bayes chain theory. Coming to the definition of cycloalkanes. Cycloalkanes are saturated hydrocarbons in which the carbon atoms are attached by single covalent bonds to form rings. Cycloalkanes belongs to the category alicyclic compounds. Means all the atoms present in the ring are same, that is carbon. Examples include cyclopropane, cyclobutane, cyclopentane and cyclohexane. Each corner of any ring represents one CH2 moiety. Nomenclature of cycloalkanes. In this, first we have to find out the parent name. For that, simply count the number of carbon atoms which are present in the ring and also in the side chain. Whichever is higher, that is considered as the parent name. In the given example, if you count the number of carbon atoms in cyclopentane, it consists of 5, whereas the side chain consists of only 1 carbon atom. Hence, cyclopentane will behave as a parent name. Then the name of the compound will be 1-methyl cyclopentane. In the next example, same you have to count both the carbon atoms in the ring and also in the side chain. Side chain consists of 5 carbon atoms, whereas ring consists of only 4 carbon atoms, that is cyclobutyl ring. Hence, the substituent or the side chain will behave as a parent name. Then the name of the compound will be 1-cyclobutyl pentane. Next, we have to discuss about how to give the numbering in cycloalkanes. Every time if you give numbering, all the substance should get least possible number. So in the given example, if you give number in anti-clockwise direction, 1, 2, 4, 3 methyl groups will get least possible number. Don't give numbering in anti-clockwise direction. So the name of the compound will be 1,2,4 trimethyl cyclohexane. If different alkyl groups are present, then you have to follow numbering according to alphabetical order. Here two alkyl groups are present. One is methyl and one is ethyl. Among these, ethyl will start with the letter E, which is a lower alphabet than the letter M. Hence, the least possibility will be gone for ethyl group than methyl group. The name of the compound will be 1-ethyl 2-methyl cyclohexane. Other than alkyl groups are present, then also you have to follow the same rule, that is give the least alphabet the least possible number. Here bromine will start with letter B. Hence the least preference will be given for bromo than methyl. The name of the compound is 1-bromo 2-methyl cyclohexane. Next we are going to discuss about the stability of cycloalkanes, which is discussed under Bayes chain theory. This theory was proposed by Adolf von Baeyer in the year 1885. His full name is John Friedrich Wilhelm Adolf von Baeyer. He is the first graduate scientist of Kekulé, and he developed this theory based upon cycloalkanes. Cycloalkanes possess different amounts of strain or stability depending upon the size of the ring. Baeyer has awarded a Nobel Prize in the year 1905 for his work with organic dyes. And one of his famous saying is as follows. Now we are going to discuss the assumptions of Bayes chain theory. Baeyer proposed his theory based upon Van 't Hoff and Label hypothesis, that is tetrahedral geometry of carbon. According to them, the bond angle between any two carbon atoms is 109 degrees 28 minutes. But Baeyer observed different bond angles for different cycloalkanes and also observed different properties and stabilities for different cycloalkanes. Based on this, he proposed a theory called as angle strain theory. According to this theory, he clearly explains the reactivity and stability of cycloalkanes. His assumption is all the carbon atoms in cycloalkanes should be planar, and it is difficult to prepare higher cycloalkanes as they are unstable and they are possessing some angle strain. Higher the strain, higher will be the instability. Higher the instability means they have increased reactivity and undergo ring opening reactions to relieve it from angle strain. These assumptions I will explain by using an example, cyclopropane. Here I have taken both 3D and 2D picture for your better understanding. In cyclopropane, the 3 carbon atoms occupy the 3 corners of equatorial triangle. Hence the bond angle will be 60 degrees. There is a deviation from normal tetrahedral angle. If bond angle deviates from normal tetrahedral angle, it produces a strain in the molecule called as angle strain. Higher the strain, higher will be the instability, and it produces increased reactivity. Hence, cyclopropane will undergo ring opening reactions to relieve it from strain. How to determine angle strain? By using formula half into 109 degrees 28 minutes directed by the bond angle in cycloalkanes. And here we are directing it by half. Why? Because the angle strain is experienced by both the sides of the equatorial triangle. So, if you make it half, 24 degrees 44 minutes is the bond angle which is experienced by each side of the cyclopropane. And these are the list of bond angles and angle strain for different cycloalkanes. According to them, if you see, next, cyclopropane also possesses torsional strain apart from angle strain. The bonds which are present on adjacent carbon atoms always try to assume staggered conformation. Any deviation from this will causes a strain called as torsional strain. In cyclopropane, the hydrogen atoms which are present on adjacent carbon atoms is in eclipsed arrangement, which is clearly seen in Newman projection of cyclopropane. So the bond angle between both the hydrogens are 0 degrees, producing some torsional strain which is causing even strain in the ring. Ring strain is also explained based upon heat of combustion. Heat of combustion is nothing but the amount of heat released when 1 mole of compound is totally burnt. And this is the formula to find out the heat of combustion. Generally, more heat per 1 CH2 moiety means that cycloalkane is less stable. And here I have given a tabular column which gives different heat of combustion values. Cyclopropane and cyclobutane will consist of more amount of heat of combustion, that is 27.6 and 26.4. But when you consider the heat of combustion from cyclopentane onwards, they are having very negligible heat of combustion. And cyclohexane even has 0 heat of combustion, stating that they are more stable when compared to cyclopropane and cyclobutane. So these are contradictory according to Bayes strain theory. Next, we will discuss about the merits and also limitations. First one is reactivity of double bond. If you consider the double bond as a two-membered ring, then the bond angle between both the carbon atoms is 0 degrees. And when you find out the angle strain, then you will get that half into 109 degrees 28 minutes minus 0 will give 54 degrees 62 minutes. This is higher when compared to all type of cycloalkanes. Therefore, alkenes are highly unstable and most reactive, which is actually true, and it goes along with the Bayes strain theory. Next, we can explain the merits based upon heat of combustion values. In the tabular column, you have seen that cyclopropane and cyclobutane has more amount of heat of combustion when compared to cyclopentane and cyclohexane onwards. So, they are having more energy, hence less stable than cyclopentane and cyclohexane. Limitations of Bayes strain theory. It explains only the relative stability of lower or smaller ring compounds and fails to explain the relative stabilities of higher cycloalkanes, that is cyclopentane onwards. The CC double bond, which is known to form easily, but according to Bayes strain theory, it is difficult to form. Why? Because it has higher angle strain and it is a highly reactive compound. And according to Bayes strain theory, heat of combustion should increase with size, and in contradictory to his prediction, Cycloalkanes from 6 carbon onwards, that is cycloheptane, cyclooctane, have practically negligible heat of combustion, which means these compounds are highly stable. And according to Bayes strain theory, these higher cycloalkanes should be increasingly unstable and undergo ring opening reactions to relieve it from strain. Contradictory to his prediction, they are quite stable and undergoes substitution reaction instead of undergoing ring opening reactions. All these limitations are overcome by based upon the theory called as Sachet-Mode theory. And the basis for him is instead of all the carbon atoms existing in same planar, if they exist in non-planar, they can easily relieve from angle strain. Cyclohexane is free from angle strain, explained based on Sachet-Mode theory. His assumptions are all the carbon atoms are non-planar and exist in puckered condition. Cyclohexane can exist either in bond or in chain conformation. And all the bonds which are present on adjacent carbon atoms are assumed in staggered conformation. There is no torsional strain. And the bond angles which are present on adjacent carbon atoms is 109 degrees 25 minutes. Hence there is no angle strain also. The left hand picture shows the chair conformation consists of only carbon atoms, and the right hand which is having both carbon atoms and hydrogen atoms. Among both bond and chair conformation is more stable. In the Newman projection, if you see, the first and fifth carbon atom is having the staggered hydrogen atoms and the bond angles is 109 degrees 5 minutes. Equatorial and axial hydrogens of cyclohexane. Cyclohexane in chair conformation has two type of hydrogen bonds which are showing either up or down. The red color bonds which are showing 3 up and 3 down are called as axial hydrogens. They are almost perpendicular to the plane of the molecule or parallel to the imaginary axis passing through the plane of the molecule. And the blue color bonds are called as equatorial bonds, which point out away from the ring or almost present lightly above or below the plane of the hexane. The axial and hydrogen atoms will exchange each other with a process called as ring flipping. In this, one of the carbon atom which is present at upper position will be changed into lower position. During this, both the axial and hydrogen atoms are exchangeable. The overall process is called as ring flipping. So based on this, Sachet has clearly explained the stability of cyclohexane and higher cycloalkanes, which couldn't be explained based upon Bayes strain theory. Thank you one and all.